In this section, what I want to do is I want to explain exactly what temperature is, which is very important to understand if we're going to work on refrigeration units. So effectively what temperature is measuring is the following. If I take a cool drink, inside we have atoms, and these atoms are vibrating and moving around. If I take my refrigeration unit, and let's pick on the insulation, these two have atoms moving around. If I take the table that my refrigeration unit is sitting on, it also has atoms moving around. So when we say the word temperature, what effectively what we're doing is we are measuring, this is the degree at which atoms are moving and vibrating. Let's take this cool drink. If we place it into a fridge that is 5 degrees Celsius, compared to the cool drink on the outside, which is sitting at an ambient temperature of 22 degrees Celsius, the atoms will be moving slightly slower than the atoms inside the cool drink that is sitting at 22 degrees Celsius ambient temperature. If we drop this temperature to something extremely cold, minus 180 degrees Celsius, these atoms will still be vibrating and moving, but again not as insane as the ones at 22 degrees Celsius. The only way we can stop these atoms from moving is by taking the temperature to minus 273.15 degrees Celsius. At this temperature, what happens is our atoms will cease to move at all. And then we have what's called is absolute zero. Now to give an idea, let's take this fridge down to minus 273. Now to give you an idea, for us to reach minus 273 degrees Celsius is almost impossible because of heat transfer. So we know that hot always moves to cold. So for instance here, the heat generated from this cool drink will move to my evaporator because we've got hot and that is cold. At the same time, while this is cooling down, the atoms from the table will be releasing heat between the table and the refrigerator. The atoms between the casing of the fridge and which is, let's say, the foam, will also be generating heat. So at some point we're always going to get some sort of influence of atoms which generate heat. These heat transfers will come in the form of conduction or radiation in this example here. So just to recap this, temperature is effectively the degree at which atoms are moving and vibrating. Now let's go back to our cool drink. There is my bottle of cool drink, and I'm going to place it in a fridge, and there is a shelf. There's my cool drink. Let's give it an evaporator, and let's say the outside temperature is a modest 22 degrees Celsius. Before we put the cool drink inside the fridge, our ambient temperature, meaning the surrounding area in our refrigerator, is sitting at 5 degrees Celsius. Now what's going to happen is, if I place this cool drink, which was outside, into a fridge, we can safely say this could be around about 18 degrees Celsius. The temperature will be different depending on the contents of that cool drink. Now, in order for this 18 degrees Celsius to drop to 5 degrees Celsius, the first law that we're going to have is radiation. What's going to happen is the heat is going to radiate off my bottle of cool drink. And as this radiates out, it collects on the evaporator, and the evaporator refrigerant will start moving it, displacing the heat outside of the refrigeration unit. The second law we're going to have is we're going to have convection. For instance, because molecules are always moving around, let's assume that this refrigerator has a fan. And what we're going to be doing with this fan, it's going to help the refrigerator get cooler faster, and we're going to have movement of air. That's your convection. You've seen this word before in stoves, especially, where all it means is that the fan inside the stove is moving the heat around the actual oven. The next law that we're going to adhere to is going to be conduction. Conduction is incredibly vague because this is in contact with my shelf, so I have conduction on between my cool drink and my shelf of my refrigerator. The other part of conduction is that as my refrigerant is running through, my atoms are starting to warm up and conducting the heat onto the evaporator, which is going to dissipate it via the refrigerant out of the fridge. So just from inside the fridge, we've gotten all three laws of heat transfer applied. So to recap these rules, again, if I take a bottle of cool drink and I place it into a fridge, it is going to, or a cold environment, it's going to radiate and dissipate heat. And because heat moves to cold, that is my radiation. If we want to talk about conduction, I'm going to try and draw a finger. Is if I touch it, the cool drink, here's my finger, that point of contact is my conduction. And if we take the convection, here's a silly little example, but let's assume my cool drink is really cold right now. Let's pretend my bottle of cool drink is sitting at, let's give it a decent 2 degrees Celsius. And if I blow here, I'm not going to draw lips, but if I move air over the bottle, and if I place my finger or my hand here, it's going to be feeling cold, because that is my convection. My heat is being moved by the air in the state of convection. Three more examples. Radiation. Let's draw the sun is radiating heat, and where I am standing, I am feeling the radiation of the sun in terms of heat. So that is going to be your radiation. Radiation, the sun, and those are the heat waves or heat rays. Conduction is if I take a pot of boiling water, there's my pot, and let's put some steam here, and if I touch this with my finger, that point of contact is my conduction. Let's give this a label so we know that this is incredibly hot. and that is going to obviously burn me. And lastly, we have our state of convection. Let's use our example of our stove, and we are going to bake a cake. Here's my cake, and we have a heating element in the oven, one at the top and one at the bottom, and we will have a fan. And what this is going to do is, as the fan blows, it will move heat around the actual oven, and that is my convection. Not a very nice fan, but you get the idea in terms of convection.